Imagine this, at the very beginning there was nothing, only darkness. And then out of that darkness came the first light. Light so old it began its journey billions of years before Earth existed, before the sun was born, before life itself began. That light has been traveling ever since. And now, for the first time, we've built something powerful enough to catch it. The James Webb Space Telescope isn't just a machine, it's a time traveler, a golden eye, floating 1,000,000 miles from Earth, listening to the oldest stories the universe has to tell. Every photon it captures is more than light, it's history. But the story Webb is showing us isn't the one we expected. Galaxies appear in places they shouldn't exist. Stars are forming far earlier than physics ever predicted. Black holes are showing up right at the dawn of time. Everywhere Webb looks, the universe seems more restless, more alive, more unpredictable than we imagined. This isn't just discovery, it's shock. It's the realization that the story of the cosmos has to be rewritten from the very beginning. Tonight we'll travel with Webb into the depths of space and the very first moments of time. What it has revealed won't just reshape science, it will challenge everything we thought we knew about galaxies, stars, and even life itself. The universe has never been silent. And now through Webb, we are finally learning how to listen.
Welcome. You are watching Whisper Science. Make sure to subscribe and join us for more amazing science content. Now, let's move back to the video.
The story of discovery rarely begins with the moment of revelation. It begins with longing, humanity's restless desire to see further, to know more, to push beyond the limits imposed by the fragile eyes of flesh and glass. For a generation, the Hubble Space Telescope had served as humanity's cosmic sentinel. Launched in 1990, it had transformed blurred smears of starlight into galaxies of spiraling fire. It revealed the pillars of creation, measured the age of the universe with unprecedented accuracy, and deepened the mystery of cosmic expansion by uncovering the enigmatic presence of dark energy. Yet as powerful as Hubble was, it remained bounded by the visible and near-infrared spectrum. The ancient light of the earliest stars, the first galaxies igniting in the cosmic dawn, lay forever hidden to its gaze. For decades, astronomers dreamt of a successor, a machine sensitive enough to pierce the veils of time, large enough to catch the faintest whispers of light stretched across billions of years. It would be a telescope not of Earth, but one that unfolded in the cold vacuum of space, far beyond the distorting breath of atmosphere. The dream was vast, and it was fragile. The James Webb Space Telescope became that dream. Conceived in the mid-1990s and built over decades of delay, revision, and near abandonment, it was one of the most ambitious scientific projects ever attempted. A mirror of gold, wider than a house, folded like an origami puzzle into the shell of an Ariane 5 rocket. Engineers compared its deployment to asking a machine to perform 1,000 flawless miracles in sequence, because one mistake, one frozen hinge, one jammed panel would doom it to silence forever. On December 25, 2021, the telescope left Earth. It rose not with the thunder of conquest, but with the fragile hopes of thousands of scientists, engineers, and dreamers who had spent their lives preparing for this moment. Days later, in the void, the unfolding began. Segment by segment, the golden mirror spread open. A sunshield the size of a tennis court unfurled with delicate precision. For weeks the world held its breath as Webb aligned itself into the most perfect optical instrument ever built. Against the odds, it succeeded. Humanity had placed a golden eye 1,000,000 miles from home, gazing outward into eternity. Then came the images. The first unveiling was not merely a press conference, it was a turning point in history. The Carina Nebula appeared, no longer a faint mist but a towering cathedral of gas and dust, sculpted by winds from massive stars. It was creation caught in the act, stellar nurseries where suns were being born, their light carving vast walls into the darkness. Webb revealed layers of detail invisible to Hubble, exposing regions where planets might be forming in dusty cocoons. Next came Stephan's quintet, a dance of 5 galaxies locked in a gravitational embrace, their arms tearing and colliding in a cosmic ballet billions of light years away. Webb's gaze penetrated the glowing dust lanes, uncovering starburst regions where tens of thousands of suns were erupting into life. Then the Southern Ring Nebula, the dying breath of a star. Hubble had shown a luminous shell, but Webb pierced deeper, revealing the binary system at its core. The smaller, fainter companion star, whose gravity shaped the gas into intricate ripples of color. Death and rebirth, caught in a single frame. And then, the deepest field ever taken. SMACS 0723. A tiny sliver of sky no larger than a grain of sand held at arm S length. Within it, thousands of galaxies appeared, layered across cosmic time. Some were so distant their light had traveled over 13 billion years to reach Webb's mirror. Gravitational lensing, Einstein's theory of relativity painted across the sky, bent the light of galaxies even further away, magnifying them into arcs and spirals. Humanity was staring back to the first 300 million years after the Big Bang, when the first sparks of structure were kindled. But it was not just the beauty that stunned scientists, it was the shock. Galaxies appeared brighter, more massive, and more organized than theory had predicted. According to models, the infant universe should have been chaotic, small clumps of matter slowly merging into larger structures. Yet Webb revealed mature galaxies existing impossibly early, as if the universe had rushed to build them long before it was thought possible. The timeline of cosmic history seemed to wobble beneath the weight of the evidence. Spectroscopy deepened the wonder. Webb was not merely a camera but a prism, splitting light into fingerprints of elements. In the atmosphere of a hot Jupiter called WSP 96b, it detected water vapor. Not drops or oceans, but the chemical traces of water molecules drifting in alien skies. On another world, carbon dioxide revealed itself, the first unambiguous detection in an exoplanet atmosphere. In distant young galaxies, Webb traced the presence of oxygen and heavy elements, evidence of the first generations of stars already living, dying, and seeding creation with the raw materials for life. The promise of Webb was being fulfilled, not in decades, but in its first months. It was as if a curtain had been torn from the stage of the universe, and humanity was witnessing an ancient performance for the first time. Scientists called it a new era of astronomy. The phrase was not hyperbole. For every image, every spectrum, every photon gathered by Webb was not just data. It was a conversation with the cosmos. Each line of light carried the memory of creation itself. And as those memories reached Earth, they began to rewrite the story humanity thought it understood about the beginning of time, the growth of galaxies, and the possibility of life beyond our world. What began as a fragile dream of engineers and astronomers had become a golden mirror into eternity. And through it, the universe was already whispering secrets no one had expected to hear. The universe has always carried the power to astonish, but astonishment is not the same as shock. Shock arrives when the fabric of certainty begins to fray, when knowledge, long thought stable, quivers in the presence of something unexpected, when the cosmos itself seems to whisper that the story we believed was written is only the faintest sketch. This was the sensation that spread across the halls of observatories, universities, and research centers after the James Webb Space Telescope opened its golden eye. The images were breathtaking, yes, but beneath the beauty, something far more unsettling lurked. Astronomers had anticipated detail, clarity, and depth beyond Hubble's reach. They expected refinement, not revolution. Instead, Webb showed galaxies where galaxies should not exist. It revealed massive luminous structures, less than 400 million years after the Big Bang, Galaxies already burning with billions of stars, organized into spirals and clusters as though time itself had bent to accelerate their creation. According to the best models, the early universe should have been clumpy and chaotic, a scattering of primitive fragments still assembling. To see entire galactic systems glowing so soon was like stumbling into a forest expecting saplings and finding towering ancient trees, their roots already deep, their crowns fully formed. The problem was not simply one of surprise, it was a direct challenge to the LCDM model, the cornerstone of modern cosmology, which described how dark matter shaped the growth of structure. In this framework, invisible filaments of dark matter formed the scaffolding upon which ordinary matter collected, slowly condensing into stars and galaxies. Growth was meant to be gradual, spanning billions of years. Yet, Webb's mirror had captured evidence of a universe that seemed to sprint when it should have crawled. Some suggested that perhaps dark matter was stranger than assumed, able to clump more quickly, or to interact with itself in subtle ways that allowed faster assembly. Others wondered if the very framework of cosmic evolution needed revision. The shock deepened further with the discovery of quasars, brilliant beacons powered by supermassive black holes, in epochs far too young to permit such titans. Black holes, according to conventional understanding, began their lives as the corpses of massive stars, feeding slowly on surrounding matter, merging with one another, swelling over billions of years into giants millions or billions of solar masses. Yet Webb revealed monsters already seated at the hearts of early galaxies, shining with furious energy less than 1 billion years after the Big Bang. It was as though skyscrapers had risen before the first bricks were laid. Did these black holes form from direct collapse, skipping the stellar stage altogether? Did they feed in ways not accounted for by current physics? Or was there some deeper principle at play, something neither Einstein's equations nor quantum mechanics had yet illuminated? At the same time, Webb sharpened an older puzzle, the Hubble tension. For years, astronomers had struggled with two incompatible measurements of the universe's expansion rate. One, drawn from the echo of the cosmic microwave background, implied a slower pace. The other, based on local measurements of galaxies and supernovae, pointed to a faster expansion. Both methods were precise, yet their values refused to converge. Webb's revelations of early, massive galaxies risked making the divide even wider. If structures appeared earlier than expected, perhaps the very assumptions that underpinned those calculations were flawed. Perhaps dark energy, the mysterious pressure accelerating the cosmos, was evolving in ways we did not yet understand. Perhaps the geometry of space-time itself carried wrinkles beyond our imagination. For the scientists who received these results, the response was not simply intellectual but visceral. Some described sleepless nights spent reanalyzing data, recalculating redshifts, testing whether the galaxies truly lay at such great distances or whether some error, some artifact of observation might be deceiving the eye. Others embraced the shock with a kind of exhilaration, calling it the most exciting crisis in modern cosmology. Conferences filled with murmurs and gasps as slides of Webb's galaxies lit the screens. Preprints flooded archive, each offering new measurements, new interpretations, new attempts to wrestle sense from the data. For decades, cosmology had stood on a foundation both elegant and confident. Now that foundation seemed to tremble. And yet, beneath the unease there was awe. Awe that the universe could surprise so profoundly. Awe that it seemed more impatient, more inventive than humanity's equations had predicted. Stars ignited sooner, galaxies bloomed earlier, black holes fed faster, complexity arose with urgency. It was as though creation itself had no interest in delay. The implications rippled outward. If galaxies appeared so soon, then the first stars, those elusive population 3 stars, forged of pure hydrogen and helium, must have lived and died earlier than ever suspected. Their deaths would have seeded the cosmos with oxygen, carbon, iron, the elements of life far sooner than expected, reshaping the chemical timeline of the universe. If black holes grew quickly, then they may not have been mere consequences of galaxies, but their architects shaping formation with gravitational authority. If dark matter or dark energy behaved differently, then the equations binding general relativity and quantum theory together might require rewriting. Each possibility carried both dread and wonder, for to rewrite the equations of the cosmos is to rewrite our very understanding of reality. The shock was not confined to scientists. Around the world, as Webb's images reached television screens, news feeds, and classrooms, ordinary people felt the tug of mystery. Few understood the mathematics behind galaxy formation, but many could sense the magnitude of the discovery. To see spirals from a time when Earth was not even dust was to feel the scale of existence with new intensity. These galaxies, impossibly old and impossibly bright, seemed to whisper of a universe rushing ahead of its own schedule, unwilling to wait for human comprehension. Stephen Hawking once wrote that the universe is not only stranger than we imagine, it is stranger than we can imagine. Webb made those words echo with newfound clarity. The shock it delivered was not just data, it was existential. It reminded humanity that every theory, every equation, every neat model of cosmic history is provisional, an approximation etched into sand, waiting for the tide of discovery to sweep it away. And now that tide had come. Science, in its truest form, is not the defense of certainty, but the embrace of astonishment. Webb had not betrayed expectation. It had fulfilled the deepest purpose of exploration, to remind us that the universe is not obligated to conform to our predictions. It is older, wilder, and far more mysterious than the human mind can yet contain. In its golden mirror, humanity saw not only the light of ancient galaxies, but the reflection of its own humility. For all our knowledge, for all our triumphs, the cosmos still has the power to shock us into silence. Light is the oldest messenger in the universe. Every photon carries a memory, a fragment of history etched into its wavelength, stretching across billions of years to reach the eyes of those who dare to build instruments sensitive enough to listen. The James Webb Space Telescope is not merely a camera, not simply a mirror gilded in gold. It is a time machine, a device built to intercept those ancient whispers of creation and translate them into meaning. To investigate what Webb has shown us is to peel back the layers of cosmic history, to touch the faint threads that weave together the origin of structure, the birth of stars, and the first chemistry of life. The investigation begins with the nature of light itself. In the expanding fabric of the universe, every wave of radiation stretches as space stretches. Light, born in the fire of the early universe, leaves its home brilliant and energetic. But by the time it reaches us billions of years later, its wavelength has been pulled into the long red glow of the infrared. Hubble could see into the near-infrared, but not far enough. Webb, with its chilled instruments and vast golden mirror, was designed to see deep into this invisible spectrum, to capture the faint echoes of galaxies and stars that no other telescope could perceive. Every photon it detects has traveled unimaginable distances, its journey lengthened by the expansion of space itself, carrying with it the story of where and when it began. Through its first spectroscopic observations, Webb showed how this principle could unlock secrets hidden in plain sight. Spectroscopy, the splitting of light into its component wavelengths, reveals fingerprints of elements and molecules. When Webb trained its instruments on exoplanets, it found not featureless atmospheres, but patterns of absorption that marked the presence of water vapor, carbon dioxide, and clouds of complex chemistry. These were not Earth-like worlds, but their skies spoke of conditions rich in molecules essential to life as we know it. The investigation of habitability had suddenly shifted from a distant aspiration into an empirical reality. The science of alien skies had begun. But Webb's investigation extended far beyond nearby planets. It turned its attention to the earliest galaxies, those faint smudges lying at the edge of the observable universe. With every measurement, it found oxygen, carbon, and other heavy elements where only hydrogen and helium were expected. According to theory, the first stars, population 3 stars, should have been vast and pure, forged from primordial gases alone. Their lives would have been short, their deaths explosive, seeding the cosmos with the first heavy elements. Webb-ES detection of oxygen and carbon in galaxies less than 500 million years old suggested that these first stars must have burned and died astonishingly quickly, enriching the cosmos with metals far earlier than imagined. The fingerprints of chemical evolution were written across the very first structures, evidence of a universe rushing to complexity. This deeper look revealed not chaos but architecture. Where theory expected only clumps and irregular fragments, Webb found galaxies with spirals, disks, and ordered structures. The presence of these forms, so soon after the Big Bang, forced investigators to question whether gravity alone could account for such elegance. Could black holes, feeding voraciously, have acted as sculptors, organizing matter into patterns even as they consumed it? Could dark matter have condensed more rapidly, weaving invisible threads that shaped luminous matter into organized systems? Each discovery sharpened the puzzle. The Southern Ring Nebula provided another window into cosmic investigation. Through Webb's infrared gaze, the death of a star became not a fading ember, but a detailed autopsy of stellar life cycles. The twin stars at its core, invisible before Webb, revealed how binary interactions sculpted the outflow of gas into intricate layers. It was a reminder that even in death, stars act as alchemists, distributing heavy elements into space to seed new generations of stars and planets. Investigating this single nebula was to witness the cycle of life and death that fuels the universe's evolution. Everywhere Webb looked, dust appeared not as a veil but as a story. Dust is the residue of ancient stars, the material from which planets form, the grains that scatter starlight and nurture chemistry. Webb uncovered dusty galaxies so early in cosmic history that their very existence defied the expected timeline. To find dust so soon was to find evidence that entire populations of stars had already lived and died, enriching their galaxies with complexity at breakneck speed. Dust is often seen as obscuration, but through Webb it became revelation, a signal of cycles repeating faster and earlier than anyone dared predict. The deeper the investigation reached, the more the universe seemed to suggest that its story was one of acceleration. Processes that should have unfolded over billions of years, star formation, chemical enrichment, black hole growth, appeared compressed into mere hundreds of millions. It was not simply that the universe had evolved differently. It was that it had evolved urgently, racing ahead of the frameworks we had constructed to explain it. And yet, the investigation was not purely one of anomalies. It was also one of connections. Webb's results linked the death of stars to the chemistry of galaxies, the growth of black holes to the architecture of cosmic structures, the presence of water and carbon dioxide in alien atmospheres to the possibility of life elsewhere. Every observation was a thread, and together they began to form a tapestry in which the early universe was not silent emptiness, but a roaring forge of creation. Scientists drawn into the investigation turned not only to Webb, but to the vast arsenal of instruments across Earth and space. Ground-based telescopes reanalyzed faint smears identified by Webb, confirming redshifts and refining distance measurements. Theorists fed Webb's data into simulations, adjusting parameters, rewriting assumptions, searching for the invisible hand that could explain such rapid evolution. Each new dataset expanded the investigation, each result pulling the mystery tighter, forcing deeper questions. The investigation was not one of despair, but of wonder. Every contradiction was also an invitation. To see galaxies impossibly early was not to witness a failure of knowledge, but to glimpse the depth of what remained hidden. The cosmos was not only larger than humanity imagined, it was more impatient, more intricate, more filled with surprises. Webb had not broken cosmology. It had revealed how much more there was to learn. By the end of its first year, Webb had shifted the focus of astronomy from the comfortable to the unknown. What was once theory became evidence. What was once prediction became shock. The investigation had only just begun, but already it was clear that the universe was demanding a new story, a deeper story, one in which the pace of creation was far swifter and the possibilities far stranger than anyone had dared believe. In every photon Webb captured, there was a memory, and in every memory there was a question waiting to be asked. The deeper the investigation went, the clearer it became that the universe was not a finished book to be read, but a living mystery unfolding, daring us to follow its light further into the unknown. The deeper the James Webb Space Telescope gazed, the more the universe seemed to respond not with answers, but with layers of questions. What had begun as astonishment soon became escalation, a chain of revelations that pushed the mystery further from resolution and closer to wonder. The cosmos, once thought mapped with elegant precision, revealed itself as more elusive, more turbulent, and more enigmatic than even the boldest predictions had allowed. At the heart of this escalation lay the crisis of cosmic expansion. For years, astronomers had wrestled with the rift between two precise but incompatible measurements of the Hubble constant. The echo of the Big Bang, frozen in the cosmic microwave background, told one story: a universe expanding at a slower rate. The flicker of supernovae in nearby galaxies told another: a universe racing apart more quickly. Webb's gaze, designed to pierce the veil of cosmic history, did not reconcile the numbers. Instead, by revealing galaxies more massive and structured at earlier times than theory permitted, it threatened to widen the rift. If the universe formed complex structures sooner, then perhaps the fabric of space-time itself had stretched in ways unaccounted for. The simple linear narrative of expansion began to fray. Dark energy, that unseen driver accelerating the cosmos, entered the mystery once more. Could it be evolving across time, waxing and waning in ways our equations had yet to capture? Or was its influence tied to properties of space itself, an emergent phenomenon rising from quantum fields too subtle to measure directly? Webb's early galaxies hinted at possibilities both thrilling and troubling, that the force governing the fate of the cosmos may not be constant at all, but shifting, whispering in tones too faint for previous generations of telescopes to hear. Beyond expansion, Webb illuminated a hidden architecture, the cosmic web of dark matter. Through gravitational lensing, where massive clusters bend light like glass, the telescope revealed galaxies stretched into arcs and spirals, their positions betraying the scaffolding of invisible matter. These distortions were not only beautiful but essential, the fingerprints of a structure that guides the luminous universe. Yet even here, anomalies arose. The patterns suggested concentrations of mass at odds with models, as though the unseen hand shaping the galaxies was heavier or differently arranged than predicted. Dark matter, long accepted as the quiet architect of structure, began to look more like an unsolved riddle, its nature concealed, its influence undeniable. In parallel, the enigma of black holes grew more pressing. Webb's discovery of supermassive black holes in epochs where only stellar nurseries should have existed forced a reconsideration of their role. Perhaps black holes were not the aftermath of galaxies, but their seeds. Perhaps from the very beginning, they sat at the centers of formation, pulling matter inward, igniting bursts of star formation in their gravitational embrace, shaping the very systems they devoured. The paradox deepened with every observation. The monsters of gravity appeared not at the end of cosmic history, but at its dawn. Dust, too, became part of the escalation. Webb's infrared vision uncovered dusty galaxies far earlier than theory allowed. Dust is not primordial. It is the byproduct of stars, ground from their atmospheres, forged in their deaths. To find it so early was to find evidence of stellar generations already past, of cycles of birth and death condensed into cosmic instants. The universe in its infancy was not sterile but fertile, producing the raw ingredients of planets and life almost as soon as it opened its eyes. Complexity was not an afterthought, but a companion to creation itself. Each revelation seemed to fold into the next, a spiral of deepening puzzles. The early galaxies called into question the scaffolding of dark matter. The black holes forced a reconsideration of cosmic chronology. The dust demanded a new understanding of stellar evolution. The expansion tension suggested a flaw in the very framework of cosmology. Instead of clarifying, Webb's findings intertwined mysteries, binding them into a web more intricate than the one it revealed in the sky. For scientists, the escalation was exhilarating and disorienting. Models once thought sufficient now strained under the weight of new data. Simulations failed to reproduce what Webb saw. Equations that had held steady for decades bent under the force of contradiction. Every new dataset became not an answer, but an invitation to rethink, to return to the drawing board, to accept that the universe was writing its own story regardless of human assumptions. Yet for all the confusion, there was also beauty. The escalation of mystery was not chaos but poetry. To see galaxies form too soon was to witness a cosmos eager to create. To find black holes at the dawn was to glimpse the power of gravity unbound. To discover dust where none should exist was to feel the breath of stars dying so their elements could enrich the universe. Each revelation carried a kind of inevitability, as though the universe itself insisted on reminding humanity that it would never be reduced to simple diagrams and equations. In every field of science, escalation is the crucible of progress. Without contradictions, without anomalies, without mysteries deepening beyond expectation, there can be no transformation. Webb's escalation of cosmic puzzles was not a failure of understanding, but the spark of a new era. It ensured that astronomy would not rest on old certainties, but push forward into the unknown. The mystery had deepened. The early universe was no longer a silent nursery, but a roaring furnace of creation, filled with galaxies, stars, black holes, and dust, forming with unanticipated urgency. The cosmos was telling us that its story was more complex, more layered, and far more profound than the neat narrative humanity had once believed. With every new observation, Webb was not merely revealing the universe. It was revealing how little we had yet grasped of its true nature. The James Webb Space Telescope did not simply deliver images. It delivered questions sharp enough to cut into the foundations of cosmology. For every galaxy it revealed where galaxies should not be, for every supermassive black hole it uncovered where only newborn stars were expected, for every chemical fingerprint etched into light from billions of years ago, it demanded an answer. Yet the answers were not singular. They fractured into theories, each one a lens through which the universe might be seen anew, each one daring to challenge the neat order of the cosmos humanity thought it had secured. To speculate in the face of Webb's revelations is not to drift into fantasy. It is to follow the evidence where it leads, even if it leads into the wilderness. Some theorists argued that the discoveries could be explained without tearing down the structure of modern cosmology. Perhaps the models of star formation efficiency were simply too conservative. If stars in the early universe converted gas into light more quickly, then galaxies might have grown faster than expected. It was not the laws of physics that needed rewriting, but the assumptions embedded in simulations. Webb, in this view, was not a herald of revolution but a correction, reminding scientists that the early universe was not as stingy with creation as they had believed. Star formation, driven by dense pockets of gas, might have proceeded with extraordinary ferocity, condensing matter into blazing clusters of suns at rates far beyond the gentle pace observed in galaxies today. In this theory, the shock of Webb's galaxies was not an impossibility, but an invitation to recalibrate expectations. But others were not convinced. The discrepancy seemed too great, the timelines too compressed, the galaxies too massive to be explained by efficiency alone. Attention turned once more to the invisible, dark matter. For decades, cosmology had leaned on dark matter as the silent architect of structure, the unseen scaffolding upon which galaxies were built. Yet Webb's galaxies hinted that perhaps this scaffolding behaved differently than predicted. The standard cold dark matter model envisioned particles moving slowly, clumping over time into vast halos that gathered gas. What if, instead, dark matter was warm, particles lighter and faster, able to smooth or accelerate the growth of structure in subtle ways? Or what if dark matter particles interacted with one another, exchanging energy, colliding, influencing their environment in ways beyond mere gravity? These variations could change the rate at which galaxies assembled, producing massive structures earlier than cold dark matter would allow. Such speculations breathed new life into particle physics, where laboratories deep underground continued to search for the elusive signatures of dark matter itself. Beyond dark matter lay an even bolder possibility that gravity itself might require revision. For over a century, Einstein's general relativity had served as the grand description of cosmic dynamics. It predicted black holes, gravitational waves, the bending of light around massive bodies, all confirmed with elegance. Yet perhaps on the largest scales or the earliest times, gravity was not as Einstein wrote it. Modified Newtonian dynamics, quantum gravity models, and emergent theories of space-time offered alternatives where the force binding the cosmos could shift under extreme conditions. If gravity were stronger in the early universe, structures might have collapsed more quickly. If it were weaker, then unseen processes might account for the anomalies. Such theories were controversial, for to question Einstein was to question the deepest framework of modern physics. Yet, Webb's discoveries pressed against the limits of orthodoxy, and where evidence strained, speculation followed. Some turned not to modifications of gravity, but to the expansion of space itself. The tension in the Hubble constant suggested that cosmic expansion was not a simple, steady process. Perhaps dark energy, the mysterious force accelerating the universe, was not a constant but a variable. In some models, it evolves across time, growing stronger or weaker, shaping the pace of structure formation. Webb's galaxies, too massive and too early, might be signposts of such a shifting force. If dark energy waxed differently in the past, if it influenced matter more directly, then the early universe could have evolved in ways current models do not anticipate. This speculation was both thrilling and troubling. Thrilling because it suggested new physics waiting to be uncovered. Troubling because it destabilized the carefully balanced equations of cosmology. There were also speculations tied to cosmic variance, the possibility that the observable universe is not representative of the whole. If humanity happens to occupy a region where conditions favored rapid early growth, then Webb's findings might reflect a local anomaly, not a universal rule. Perhaps in the grand average of creation, galaxies did form slowly, but in our corner of space-time, they ignited with urgency. This possibility was difficult to test, for we are confined to a single vantage point. Yet it reminded investigators of the humbling truth that the observable universe is not the universe entire. What Webb shows us may be profound, but it is only a fraction of the whole. More speculative still were ideas that reached beyond the Big Bang itself. Some cosmologists wondered if Webb's galaxies hinted at conditions predating the universe as we know it. Were there fluctuations or imprints from a prior cosmic cycle, a bounce or echo from a universe before ours? Could the anomalies Webb revealed be scars of physics that transcend the singularity, evidence of a multiverse pressing against the edges of our perception? These were speculations on the frontier, precarious and unproven, yet magnetically attractive in the face of mysteries that defied simpler explanations. To imagine that Webb was not only seeing galaxies, but also catching glimpses of a deeper layered reality, was to step into the most daring regions of thought. In parallel with cosmology, Webb stirred speculation in the search for life. The detection of water vapor, carbon dioxide, and clouds in exoplanet atmospheres suggested that the ingredients of habitability were common. If such molecules were present in the first data, then what might a decade of observations reveal? Would Webb identify biosignatures, oxygen, methane, or chemical imbalances that hint at biology in the skies of distant worlds? If galaxies rushed to complexity, if stars lived and died with haste, then perhaps the chemistry of life also emerged earlier than expected. The possibility that Webb-ES instruments might one day reveal evidence of living processes beyond Earth infused speculation with a sense of urgency. Life, it seemed, might not be a late arrival in the cosmic timeline, but a companion present from early chapters of creation. Some thinkers on the edge of science and philosophy dared to ask whether Webb might stumble upon signs not of simple life, but of intelligence. The telescope was not built for such a search, yet its capacity to resolve faint structures and detect unusual spectra opened the door, however slightly, to the possibility of technosignatures. Could a distant Dyson sphere, a structure built to harness starlight, cast a shadow in Webb's data? Could artificial chemistry betray the presence of civilizations older than Earth, civilizations that perhaps rose and fell before our sun was born? The speculation was careful, grounded in the absence of evidence, but the very act of asking revealed how Webb stretched the imagination toward possibilities once confined to science fiction. As the theories multiplied, one thread wove them together: humility. Each speculation, from modified gravity to multiverses, from evolving dark energy to ancient civilizations, acknowledged that Webb had shown us how little we truly know. The telescope had not invalidated science, but deepened it, pushing the boundaries of what required explanation. In every conference hall, in every published paper, the tone was the same. Webb had shifted the ground, and the future of cosmology would be written in response to its revelations. Speculation is often misunderstood as weakness, as though science should only speak in certainties. But in truth, speculation is the engine of discovery. Without daring to imagine what might be, humanity would never have built the instruments to see what is. Theories, even when wrong, carve paths through the unknown. They prepare the mind to recognize truth when it finally appears. Webb's revelations demanded such preparation. They demanded imagination, the courage to embrace possibilities as vast as the universe itself. In the long history of science, every major discovery has been preceded by a season of speculation. Newton speculated about the nature of gravity before writing its law. Einstein speculated about the nature of light before deriving relativity. Hawking speculated about the behavior of black holes before evidence confirmed his ideas. Webb had brought the cosmos to a similar threshold. Theories and speculations would now swirl, some to fade, others to evolve into the next pillars of understanding. And so the story of Webb is not only the story of galaxies and light, but of minds set free to dream within the boundaries of evidence. The telescope has not only shown us the distant past, it has shown us our own future, a future where every anomaly becomes an opening, every contradiction a question, every fragment of light a doorway into deeper mysteries. The theories will compete, the speculations will multiply, and through them the universe will continue to astonish. For in the end, speculation is not departure from reality, but its most faithful companion. To speculate is to admit that reality is greater than our grasp, that truth is always larger than our certainties. And with Webb's golden mirror reflecting the oldest light in the cosmos, speculation has never been more necessary nor more beautiful. The discoveries of the James Webb Space Telescope did not arrive as isolated marvels, like gems uncovered by accident. They were the product of tools, precise, delicate, and unimaginably complex, designed to transform the faintest whispers of light into revelation. To understand how Webb continues to push the boundaries of human knowledge is to step inside the machinery of discovery itself, to see how golden mirrors, prisms, detectors, and algorithms combine to probe mysteries that lie billions of years away. This chapter is not only about a telescope, but about the arsenal of instruments, collaborations, and tests that make it possible for humanity to wrestle meaning from the cosmos. At the heart of Webb's vision lies its segmented mirror, a mosaic of beryllium coated in gold. Each segment was polished to atomic precision, shaped so finely that the largest imperfection is measured in fractions of a wavelength of light. When deployed, these 18 pieces became one, adjusted by tiny motors until their reflections overlapped with perfect harmony. This mirror is not simply a window. It is a collector of ancient time, large enough to capture photons that have traveled across the entire age of the universe. Without it, the deep field of SMACS 0723 would remain invisible, its galaxies lost in darkness. Yet the mirror alone is not enough. Webb's instruments transform raw light into knowledge. NIR-CAM, the near-infrared camera, provides the telescope's wide and deep view, peering into regions where stars are born and galaxies first emerged. Its detectors are sensitive to wavelengths that human eyes cannot see, revealing structures hidden behind cosmic dust. NIR-SPEC, the near-infrared spectrograph, takes those views further, splitting light into spectra to decode the elements present in stars, galaxies, and planetary atmospheres. It is through NIR-SPEC that Webb detected water vapor and carbon dioxide in alien skies, reading chemistry across unimaginable distances. MIRI, the mid-infrared instrument, extends the gaze deeper still, sensitive to longer wavelengths that carry the heat of distant exoplanets, nebulae, and faint galaxies. Each instrument is like a sense organ in a body greater than any individual, together granting humanity vision across realms of light denied to natural sight. But instruments, no matter how advanced, demand precision. Webb is not stationed on Earth, where technicians could tighten bolts or replace parts. It orbits at the second Lagrange point, 1,000,000 miles away, held steady in a delicate balance of gravity and centrifugal force. To function there, it must maintain temperatures near absolute zero, shielded from the sun's radiation by a sun shield the size of a tennis court. That sun shield, composed of 5 layers of reflective film thinner than a human hair, allows the instruments to remain cold enough to detect faint infrared signals without interference from their own heat. Without that chill, the telescope would be blinded by its own warmth. Every observation Webb conducts is the product of ongoing calibration. Mirrors shift and are adjusted. Detectors are tested for noise and interference. Data streams to Earth and is checked against expectations. The process is relentless, because a telescope of this sensitivity does not simply open its eyes and see perfectly. It must learn to see, aligning itself again and again, refining its instruments until every photon falls exactly where it belongs. The act of ongoing testing is as vital as the act of discovery itself, and Webb does not work alone. Its revelations are compared, tested, and challenged by other instruments across Earth and sky. Ground-based telescopes such as the Very Large Telescope in Chile, the Keck Observatory in Hawaii, and the Atacama Large Millimeter Array provide complementary data, observing in wavelengths Webb cannot access, confirming redshifts, mapping gas flows, measuring stellar populations. Soon, the extremely large telescope will rise in the Chilean desert, a giant mirror 39 meters across, designed to work alongside Webb in probing the deepest mysteries. The synergy between instruments is not competition, but collaboration. Each telescope a voice in a cosmic symphony, each adding detail, correction, and verification. Ongoing testing extends into the realm of theory. Every dataset from Webb becomes input for simulations, run on the most powerful supercomputers humanity has built. These simulations recreate the birth of galaxies, the collapse of stars, the spread of chemical elements. They are tested against Webb's findings, their parameters adjusted until models align with reality. When they fail, as they often do in the face of Webb's shocking galaxies, they force theorists to refine their understanding, to revise assumptions, to accept that nature writes laws more subtle than human minds once imagined. Artificial intelligence has become part of this testing process. Algorithms trained to recognize faint signals sift through Webb's immense datasets, identifying galaxies, exoplanets, and chemical features hidden in noise. Without such tools, the sheer volume of information would overwhelm human researchers. Terabytes of data flow from Webb each month, and with every observation, the universe grows more detailed. Testing now means not only verifying what Webb sees, but also developing the computational power to comprehend it. The lifespan of Webb itself is finite, but ongoing testing ensures that every year it operates is one of precision. Engineers estimate its fuel reserves may allow it to function for 2 decades, perhaps longer if its systems remain stable. During that time, the telescope will continue to refine its vision, peering deeper into cosmic dawn, probing exoplanets for biosignatures, mapping the chemistry of galaxies. Each test, each calibration, each adjustment keeps its golden eye focused on the oldest light in existence. The ongoing testing is not limited to instruments and theories. It extends to the scientific community itself, which tests every claim, every interpretation, every conclusion drawn from Webb's data. Papers are scrutinized, redshifts debated, models compared. The process is often slow, sometimes contentious, but it is the essence of science. No revelation is accepted without trial, no claim stands without evidence. Webb has escalated mysteries, but it has also renewed the culture of testing, reminding scientists that astonishment must always be followed by discipline. What makes these tools and tests remarkable is not only their precision, but their philosophy. They embody the recognition that the universe will never surrender its secrets easily. To wrest meaning from ancient light requires not only vision, but humility. The telescope must test itself, scientists must test their theories, and humanity must test its willingness to embrace the unknown. Webb is not a single machine, but part of a greater network of inquiry, a collaboration that stretches across continents and decades, uniting engineers, astronomers, physicists, and dreamers in a common pursuit. The tools continue to refine, the testing continues to deepen, and with every cycle the universe yields a little more of its story. Yet for every answer, more questions arise. The galaxies are too old, the black holes too massive, the dust too abundant, the expansion too strange. No matter how advanced the tools, no matter how rigorous the testing, the cosmos remains elusive, daring humanity to build even greater instruments, to develop even sharper theories, to keep listening to its oldest messengers of light. And so, the story of Webb is not only about what it has already shown, but about the tools and tests that will shape what comes next. It is about the unfolding of a process where discovery is not a moment but a continuum, a dialogue between the universe and those who dare to listen. Each calibration, each spectrograph, each supercomputer run is part of that dialogue, refining the voice of the cosmos until its whispers become sentences, until its secrets become stories, until its mysteries become the next foundation of knowledge. Webb is the most powerful telescope humanity has built, but it will not be the last. The Roman Space Telescope waits on the horizon. Giant observatories on Earth are nearing completion. Future instruments may probe gravitational waves with the same sensitivity Webb has brought to light, or measure neutrinos born in stellar hearts. The tools will multiply, the testing will continue, and the mysteries Webb has unveiled will become the guiding questions of a new scientific age. For now, every photon Webb gathers is tested, calibrated, compared, and retested, until meaning emerges. Each one is a memory of creation, a fragment of history turned into knowledge. The tools are the hands, the testing is the breath, and together they make possible the song of the universe Webb has begun to play. The James Webb Space Telescope is often described as a machine, a marvel of engineering, a mirror polished to impossible precision. But when one steps back from the mathematics, from the calibrations and the data streams, what remains is not a machine at all. It is a mirror into human longing. Its golden petals, suspended 1,000,000 miles from Earth, are not merely collectors of light. They are collectors of meaning, instruments through which humanity gazes at itself across the gulf of time. For what does it mean that the universe reveals galaxies too early, stars too massive, black holes too hungry, dust too abundant? What does it mean that the timeline of creation, thought secure, now trembles with uncertainty? It means perhaps that the universe is reminding us of our place. Every equation we write, every model we construct, is provisional, a scaffolding of thought fragile before the immensity of reality. Webb has shown that no matter how far our knowledge extends, there will always be more beyond it. The cosmos is not an answer to be solved, but a question to be lived with. There is humility in this realization, but also wonder. To stand on a small planet, orbiting an ordinary star, and to build a mirror that can catch the faint glow of galaxies billions of years old, is to participate in something extraordinary. It is to acknowledge that the universe is not indifferent but generous, offering its secrets to those who are patient enough to listen. Light does not lie. It travels across unimaginable distances, carrying with it the memory of its birth, waiting for eyes that can decode it. That we have become such eyes is not simply an achievement of science, it is a statement of who we are as a species. The images Webb has delivered, the towering clouds of Carina, the dying light of the Southern Ring Nebula, the dance of Stephan's Quintet, the deep field of SMACS 0723, are not just photographs. They are chapters of an ancient story unfolding in silence. They remind us that creation is not a past event, but an ongoing process, still alive, still shaping, still expanding. They remind us that the universe does not move slowly toward death, but rushes constantly into new forms, new structures, new mysteries. And in those reminders lies a deeper reflection. If the universe rushed to complexity sooner than expected, if stars and galaxies and black holes appeared almost instantly after the dawn, then perhaps complexity itself is woven into the fabric of reality. Perhaps life too is not an accident, but a consequence of a cosmos eager to generate order, eager to create structures that can perceive and reflect upon it. In this possibility lies a profound intimacy. The universe does not merely exist outside of us, it exists through us, seeing itself through our eyes, understanding itself through our thought. This is the emotional truth that Webb forces upon us, that we are not spectators of the cosmos, but participants in it. The same carbon and oxygen Webb detects in galaxies 13 billion years old are the carbon in our bones, the oxygen in our breath. The same processes that enriched early galaxies enriched the matter that became Earth. When Webb looks back to cosmic dawn, it is not looking at something alien. It is looking at our own beginning, the long arc of history that led to a species able to wonder about it. And so the telescope's discoveries are not only scientific shocks or cosmological puzzles, they are philosophical invitations. They ask us to consider not just how galaxies form, but why there is something rather than nothing. They ask us to consider not just the physics of black holes, but the meaning of a universe that produces structures capable of awe. They ask us to reflect on our fragility, our smallness, and yet also our capacity to build instruments that stretch across time itself. Perhaps the greatest gift Webb has given is not its data, but its perspective. It reminds us that our world, with its boundaries and conflicts, is suspended within a vastness so immense that it renders divisions trivial. From Webb's vantage, Earth is invisible, its noise swallowed by silence. And yet from that silence we dare to send questions, and the universe dares to respond in light. In the end, what Webb has shown is that the cosmos is not silent after all. It speaks in the language of ancient photons, in the glow of galaxies formed when time itself was young. It speaks through the rise and fall of stars, through the collapse of black holes, through the chemistry of alien skies. It speaks in ways subtle and profound, and it speaks always to the same truth, that we are part of it. The philosophical reflection closes then, not in certainty, but in wonder. For if the universe is more urgent, more fertile, more inventive than we believed, then so too is the future of our understanding. Webb has opened a new era, one where every observation is both an answer and a question, both a discovery and a mystery. To live in such an era is to live in a time of extraordinary grace, when the universe itself invites us to listen. And so the final image is this: a golden mirror suspended in darkness, capturing light older than Earth, older than the sun, older than memory itself. That light travels across eternity, strikes the mirror, passes through prisms, is translated into data, and finally into understanding. It arrives not to machines alone, but to minds capable of wonder. It reminds us that we are children of stars, seekers of truth, listeners to the oldest songs in existence. The universe is not finished, neither is our search. And through Webb, humanity has taken one more step into the infinite, guided not by certainty, but by awe.